did my presentation on interplanetary constitutionalism, Martian Constitution. And I just wanted to start off by asking, with a show of virtual hands, if I can see virtual hands, let me open the participants. If you had the opportunity to go to Mars today, would you go? If there was like yeah, okay, we have a few. Awesome. All right. Yeah, I see. Wow, there's way more people than I thought there would be. Okay. Anybody who just raised your hand, would you mind like just unmuting for 2 seconds and saying like just a few words of why you would go?
Just once in a lifetime experience, right? Even if I died there, I'd still do it. I wouldn't want to miss the opportunity.
Thank you, Angela. Okay, that's perfect. Yeah, the novelty. I get it. I get it. That's very similar for me. I don't think it would be a one-way trip, or I hope it wouldn't be. But I would similarly like to do it for the novelty. Anywho, I just thought that would be a fun way to start out my presentation. But I also think that this quote by just 1 second, my slides are moving. Okay, this quote by Sarah Stewart Johnson, who's a planetary scientist. She says, "Mars has been our mirror, our foil, a telltale reflection of what has been deepest in our hearts. We have seen in Mars a utopia, a wilderness, a sanctuary, an oracle. With so few landmarks, guideposts, or constraints, all is possible. Without data that could be used to cabin our inquiry or limit our imagination, Mars has been a blank canvas, and tenderly our human seeking has rushed to fill it." And I wanted to include this quote here and in my paper as well, because I do think this idealism of Mars as a blank canvas or utopia allows the fascination with it to persist. And just for some context here, I did a space law directed study with Professor Dillon last semester and wrote about the right to vote from outer space and how that could reinforce the right to vote on Earth. I've also written about legal black holes in outer space, which are spaces just beyond the reach of enforceable law. Examples on Earth include the Guantanamo Bay Detention Center and migrant drownings. I wrote about the endless legal black holes in outer space in order to argue that if there are places or spaces where law cannot be enforced, specifically violations of Jus Cogens norms, which are preemptory norms of international law, then these places or spaces undermine the rule of law on Earth. And if I lost you, that's okay. This is just background to say that my perspective on viewing these legal issues in the context of outer space is not an escapist one, but rather a pragmatic approach building upon the inevitable innovations and explorations of others to see how rights can be reinforced and how the rule of law can be upheld on Earth via those innovations and explorations. And to start, I think it's relevant to discuss a Martian constitution because I think it can help guide current constitutionalism on Earth. Specifically, I discuss in my paper that rethinking traditional notions of jurisdiction, or as I refer to them throughout my presentation and in my paper, zones of sovereignty, should guide governments through the technological innovations of the 21st century. And I will. Okay, and so I did want to just start with a few facts about Mars. And so the first thing I wanted to share was a kind of a give you guys a perspective of the size of Mars in comparison to Earth. And so it is half the size of Earth, and it's twice the size of Earth's moon. But for me, this didn't really help me conceptualize it. So NASA has this fun way of picturing it. And so if you picture a house, and then NASA tells us that if the sun were as tall as a typical front door, Earth would be the size of a dime, and Mars would be about as big as an aspirin tablet. And so this is just another way to conceptualize the size of what we're talking about here. One other way here to conceptualize this, sorry, I'm just moving something over. Another way to conceptualize this is this image. I don't know if this helps that much, but it's just the United States superimposed upon Mars. It is a NASA image. It's just another way to conceptualize it. Another Mars fact, Mars has two moons. One is Phobos and one is Deimos. A Martian day, referred to as a soul. If you've seen the movie The Martian, you are very acquainted with this terminology. It's approximately 40 minutes longer than a day on Earth. And this makes a Martian year 687 days. But, and I love this fact, you wouldn't age any quicker. And so living on Mars, you'd only be celebrating a birthday roughly every 2 years, since a birthday is marking another orbit around the sun. And then on Mars, we would experience 62.5% less gravity than we do on Earth. And so since gravity is a measure, since weight is a measure of gravity's effect on mass, if you weigh 100 pounds on Earth, you would weigh only 38 pounds on Mars. And so that's it for the fun facts. But this is a future concept image published by NASA actually just last week. So this is not the current reality, but NASA does currently have two rovers, Curiosity and Perseverance, which look like the two rovers pictured on the, I don't know if you can see my cursor, but pictured on the left here. And one lander, Insight, which looks like the lander in the back center here. And one helicopter, Ingenuity, which is not pictured, currently exploring the surface of Mars. But this is a future, again, this is a future concept image NASA published last week of what they hope to have future missions in the coming years performing. And so to get into my presentation, why Mars? Why would Mars be right for an independent constitution? Why not other planets or moons? And in order to answer this question, I think we need to first ask, why not the moon? Excuse me? Oh, here. Matthew, I think you're unmuted. Anyway, I'm just going to keep going. So the conclusion here that I came to, and that seems widely accepted, is that it would be impossible to bifurcate the governance of the Earth-Moon system because of the reciprocal reliance the system has upon each other. So the moon and Earth are like, they're very reliant on each other. Examples of this, people on Earth derive benefits from the moon, and any colonies that would be developed on the moon would likewise derive similar benefits from Earth. The moon provides people on Earth with the constants of the tides, the light at night, and even the moon potentially regulates the amount the Earth tilts on its axis. The moon is also served as a research hub, similarly to the concept image that I just showed you guys. NASA has rovers and things on the moon, and it's served as a research hub and provided people with a wealth of data into the formation and evolution of the Earth-Moon system. And unlike this Earth-Moon connection, there is no similar Earth-Mars connection. The relative distance from Earth to Mars is always greater than that to the moon. And this is legally significant since travel to Mars, at least initially, is likely to take at least 6 months, and any type of extradition or enforcement of Earth's laws on Mars via this timeline would be untenable and really undermine the rule of law in any system of justice on Earth. And also, the specific interest for human settlement on Mars has developed and continues to evolve, but the reasons for some that I've already mentioned, the reasons that people have for human settlement on Mars include some that I've already mentioned, but also other than Earth, Mars is the most capable planet in the solar system of sustaining human life. This is due to several factors, including its dry land, the gravity and temperature all being within human tolerance. Mars has a lot of chemical resources, and it is also believed that liquid water exists beneath the Mars surface. I also just wanted to show you some more NASA concept images of what a Martian colony could look like. These are official NASA images. And so I'll just leave this one up for a minute. As you can see, there's research going on in and outside of a Martian colony here. And then the next one here kind of looks like what was going on in the movie The Martian. And again, this is NASA images. So here I just wanted to show you guys actually a video of the zone of sovereignty I was referring to in my intro. And I will start this here. Let's see. I might have to reshare. Let's see. Bear with me. Can you guys still see it? Cool. I don't know if it's okay. Can you hear
these
it?
halo orbits can
Cool.
pretty large. They can be as large as hundreds of thousands of kilometers in radius. And so to kind of properly encompass the use of these spaces, we probably want to define something like this: a sphere of near Martian space, which would be 1.5 million kilometers in radius. Now, I need to give a quick disclaimer about this diagram. It's not to scale. So this sphere is 1.5 million kilometers. The distance from Mars to the Sun is about 228 million kilometers. So this is a very distorted image to kind of zoom in on space around Mars, but this is actually a very small fraction of the distance from Mars to the Sun, and indeed a very small fraction of the distance from Earth to Mars. At the closest approach, this is about 3% of the distance of Earth to Mars. So we're not encroaching on anyone else's space here. This is very much just around Mars itself. But the idea is then that this sphere of immediate near Martian space would then become part of the political definition of Mars, a bit like national airspace and territorial waters of nations on Earth. It's a region around this country that you need to kind of get in and out and you can make use of and derive benefit from. And so this region too then would also be under the sole sovereignty of the collective people of Mars. Now, as you can see from this diagram, the story is even bigger than that. So beyond Martian orbit, there are three other Lagrangian points, these balance points within the Sun-Mars system. So there's L3, which sits on the other side of the Sun from Mars. Now, we don't use L3 currently in the Earth-Sun system, but a number of uses have been proposed, such as a sunspot warning system, for example. And you could foresee having this having kind of security implications, given that if you put something at L3, you're basically hiding something behind the Sun from a planet. So in order to avoid any kind of nefarious shenanigans going on there, it's probably important for a planet to have awareness of its own L3 points and kind of jurisdiction over it. The other Lagrangian points are L4 and L5. Now, these are a bit different in that they're very stable. So objects that sit in these regions kind of tend to stay there, which means that, so they sit about 60 degrees ahead of and behind a planet respectively, and they tend to gather lots of dust and potentially asteroids as well, which we call Trojans. Now, the Earth-Sun system, I think, has one Trojan that we're aware of in L4 of the Earth-Sun system. Mars actually has 9 Trojans that we're aware of as of 2021, distributed between the two regions. And again, while we don't use these regions yet in our Earth-Sun system, there's still been sort of scientific missions that have flown by. There's more future scientific missions proposed to use them in the future. And they might have use for things like space stations as well. And as well as these points, there's plenty of use for the rest of just the Martian orbit in general as well. There are things called planet trailing orbits, which is a very fuel efficient way of keeping a satellite kind of close to a planet and sort of dropping behind year by year during the operation of the mission. So scientific satellites, Spitzer and Kepler use that kind of an orbit. And then also ahead of the planet, there's things like the method of ballistic capture or low energy transfer, which is a very fuel efficient way of transporting materials to Mars from Earth without using the Hohmann transfer, which is useful, but it's bound by the fact that it has these very narrow launch windows. In the future, if you had non-time critical deliveries to make to Mars, then you might put an object basically ahead of Mars in its orbit and then let the planet catch up to it. And so that's then a use of kind of the orbital space ahead of Mars as well. So all taken together with the fact that then Mars and its associated Hill sphere is orbiting around the Sun over the course of a year, it makes sense then to define a sort of a torus, a donut in shape, which would then be the complete Martian zone of sovereignty. So this would then basically be the width of the near Martian sphere which is 1.5 million kilometers, as I described before. And then its radius would be the 228 million kilometers between Mars and the Sun. This would be basically one big torus that would encompass the entirety of the Martian orbit and would include all celestial bodies within the region, including the planet Mars, its moons, and the Martian troposphere. And much like maritime boundaries or airspace.
And so I'm just going to stop it there and hopefully be able to return to my presentation. I might have to do a new share. I don't know what you guys are seeing on my screen. Okay, cool. Is it back at the presentation? Awesome. All right. And so obviously you heard her talk about the torus. And so what I was proposing, and I see even Eric's question in the chat. And so my paper proposes that something similar to this would be beneficial as a zone of sovereignty for Earth, especially taking into account technological innovations of the 21st century. And just as I conclude, I don't know if anyone is familiar with Yuval Noah Harari, but he is a historian, philosopher, and well-known author of Sapiens, Homo Deus, and 21 Lessons for the 21st Century. And I use this quote by him in my paper. He says, "The only real solution is to globalize politics. This does not mean establishing a global government, a doubtful and unrealistic vision. Rather, to globalize politics means that political dynamics within countries and even cities should give far more weight to global problems and interests." And using this quote, I argue that an effort to not only conceptualize, but to enshrine Earth's zone of sovereignty, meaning that torus, would pay dividends to guiding governments through the technological innovations of the 21st century. And with that, I conclude, and thank you for coming to space with me today, guys.